In this video, we will be doing this Leetcode question partition list, and in which you will be given the head of a linked list and a value x. So we have to partition it in such that all the nodes less than x come before the nodes which are greater than or equal to x. And you should preserve the original relative order of the nodes in each of the two partitions. So what this actually means, so let's say this is our linked list given, and the value of x that is given, let's say it's 4, and I just really need to do one thing. I have to take all of the nodes which are less than this x, and I have to put them on the left side of this x, or any value which is greater than x. So what I actually mean is that I'm going to take, firstly I'm going to see that which nodes having the value which is less than x, less than this x. So if I see that this 3, so if I see this 3, this 2 and this 1 have a value which is less than this x that is given. So what I'm going to do is that I'm going to take a new, so I'm going to take this 3, 2 and 1 and I'm going to put them here. After that I'm going to continue this with 5 because 5 left, and then I have this 4 and then I have this 6. I'm just pointing to no. So now you can see this thing that this is my x value, and this is the value which is greater than x, and this is the value which is greater than x. So all of these values are equal or greater than x, and all of these values are smaller than this x, and that's how I have to partition them. I just need to do one thing. I have to take all of the nodes which have a value less than this x, and I have to put them on the left side from the starting, and whatever nodes that's gonna be left nodes, they will gonna come automatically on the right side, and our list will gonna get partitioned. So how are we gonna do this? And there's one more thing was there that you need to keep in mind, the relative order. So relative order basically means that if you see here in the original linked list, this 2 is coming after 3, and this one is coming after 2. So if you see here in this linked list also, this 2 is coming after 3 and this one is coming after 2. And for this 6 is coming after this 5. So in here also this 6 is coming after the 5. This 4 is coming after 5 and before 6. So you basically need to put them into the same order as they were before. So if 6 is ahead, if 6 is ahead, then it should be ahead here also. Okay. So that's how you have to partition. So let's see how we can do this. So one thing that you need to keep in mind, that you have to just take all of the nodes which have a value less than x and put them on the left side. Okay, so if you take a pointer, let's say pointing to head, and then you're going to check the value of this pointer to this x, you will going to find that this is greater. So you're not going to touch it and you just have to move ahead. So you're going to put this pointer here. And now you're going to check the value of this node with this x. So you're going to find out that this node is having a value which is smaller than this x. So you're going to take this node from here and going to put it separately somewhere here outside of the list. So let's say I put it here. Okay. And then I'm going to connect my 5 and 2 together. And I'm going to remove this pointer from here and I'm going to move it here. Okay. Then I'm going to check again, is this 2 is smaller than my x? Then I'm going to see that yeah, it is smaller. So I'm going to take this value from here and I'm going to attach it here with this 3. Okay. Then I'm going to take my pointer that will be pointing here on the 4, and after that I'm going to rub this, and then I'm going to check that is this value smaller than this x. So I'm going to see that it's not smaller, it's actually equal. So even if it's equal, we're still going to move ahead. We just only have to check which values are strictly smaller. Now I'm going to check for this one. So as 1 is smaller than x, so I'm going to take 1 from here and I'm going to attach it with this 2. And then I'm going to move my pointer ahead here on 6 and I'm going to check again, is this 6 greater than 4 or not? So then I'm going to check again, is this 6 smaller and smaller than x or not? So as I'm going to see that it's greater, so I'm not going to touch it. I'm going to move my pointer ahead, and my pointer is pointing to null now, which means my list is ended and I don't have to check anymore. So if you see that this is our right part and this is our left part, and that's what we wanted. So what if I do one thing, that I will take this left part and attach it here. How can I do that? So firstly I will make this list properly. So my 5 is pointing to my 4. I'm simply gonna take this whole node and I'm gonna attach it right here. Okay, this one will be pointing to this 5, and that's what we wanted in our answer, and that's how we're gonna do it. Okay, so one of the things is that you cannot actually do this with just one pointer, because we are actually connecting nodes also. Okay, so we see there what I'm actually saying. So I'm gonna take my linked list again, and my value of x that was given, it was 4. Okay, so I have to take all of the values which are less than x on the left side. Okay, left side. So if you see this thing, when I was removing this 3 from here, I was connecting this node to this node. But how can I connect if I don't have any pointer to these nodes? If I don't have any pointer on these nodes, I cannot connect them. Okay, because only my current pointer was working, which was busy in checking the node's value. But I need to have some pointer here and here also for the purpose of connecting them. So to do that, I'm simply going to take a previous pointer here, and I'm going to take my 3 back, and my current pointer was pointing here. What I can do is that I can take a dummy node. I'm going to create a dummy node right here, and let's say the value storing it's 0, and I'm going to point this current value here. So what I'm going to do is that I'm going to attach all the current values to this dummy node again and again, and after that I can delete the dummy. Okay, so let's see what is the actual use of it. So as my current came here, okay, as my current is here now, I have to take this node and I'm gonna put it here. Okay, so let's say there is a pointer that is pointing here on this dummy. Let's say that is tail. So what I'm gonna do is that I'm gonna make my tails next. Right now my tails next is null. I'm gonna make my tails next this current. So if I do that, like I'm gonna make my tails next equals to my current. Right now my current is this. Even before this, I need to save this node also, otherwise I'm gonna lose the connection for this node. So saving this node basically means that just take a pointer and put it here. Every time you have this current, just declare a pointer, let's say this list node star forward pointer, and I'm gonna make that pointer as my current next. Okay, so as soon as I finds out this thing that my current is actually having a value which is smaller than my x, then I'm simply gonna take a pointer which will be pointing to the next of the node, next of this current. Okay, right now this 2 is my next, so I just declare this pointer forward which will be pointing to that next. Okay, what is the benefit of this? So when I'm gonna remove this, when I'm gonna make my tails next my current, my tail will gonna get removed from here, and my current will simply gonna point here. Okay, so it's like that my 3 will gonna point here now. Okay, and this is my current here. Now I need something to attach these two values together so that I can continue in my linked list and I can complete my linked list. So to attach these two together, my previous with my forward, I can simply write make my previous next equals to forward. Forward here is forward node. Okay, so when I'm gonna do this, this previous will simply gonna point to this 2. Okay, after that I have to check for this 2 also. Is this 2 is smaller than x or not? So to do that, I'm gonna remove my current from here and I'm gonna point my current where there is my forward. Right now my forward is here and I have to check for this node, so I'm simply gonna write make my current my forward. So my current will also gonna point here now and my forward is still gonna be there. Okay, Now as I can see this thing that this value is smaller than x, so this value should come here. Okay, so I'm going to take this value from here and I'm going to put it right here. This is my current that is pointing here. Okay, now when I find out this thing that my current is having a value which is smaller than my x, then what I'm going to do is that I have to do this thing that I have to save the next node so that I can connect this previous to this 4. So I'm going to save the next node. I'm going to still move this forward ahead. So I know my current is this because I did this. So I'm going to move my current, my forward ahead. So my forward will going to move by doing the currents next. So this is my currents next. And after that my forward will going to point here now. Okay. Then this 2 will gonna come after this 3 and my current will gonna point here because I did my tails next equals to current. And you have to keep this thing also in mind that this tail should move ahead too, so that you can make this tails next ahead, tails next current. If you're not gonna do this, your tail will still gonna point here and you will not gonna be able to attach this current from here. So to do that, I'm gonna point my tail here, and after that I can simply connect my tails next to my current. Okay, then my current is gone from here and I'm gonna use this previous next 4 line and I'm gonna connect this 4 with this. I'm gonna connect this 5 with this 4. Okay, then I'm gonna do the same thing. I'm gonna make my current, I'm gonna remove my current from here and I'm gonna point it towards this forward. And after that I'm going to move my forward ahead only and only if I really think that the number is the value in this current is smaller than this x. So right now I can see that my value is not smaller, it's not greater. So as I can see that right now that my value in this current is equals to my x. So basically I'm not going to do anything, I'm not going to execute any of these lines. I'm simply going to move my previous and my current ahead so that I can check for this, and if this is smaller then I simply can connect by using my previous, this and this. Okay, so for this you can forget this forward from here and you can simply move your previous and your current one step ahead. So I'm gonna put my current here and I'm gonna put my previous here. Okay, so one thing if you notice that I was doing all of these steps when my current's value was smaller than this x, and when it's greater and when the value is greater I simply moves my previous 1 step ahead and my current also 1 step ahead. This is when current value is greater than or equals to x. Okay, and this is when it's smaller. So right now my current is pointing to this 1 and I know this thing that this value is smaller than x. Then same thing gonna happen, this current, this tail will gonna move ahead firstly, and then my tails next will gonna become this current. So I'm gonna remove my current and my tails next will gonna become this current which is 1, and after that my previous next will gonna become this forward. So even before you take your current here, like my current is pointing here, when my current was here, before this my current was here, right, and I simply have to make this forward and current, like forward equals to currents next, so that I can save this node. I'm gonna put my forward here and then I'm gonna send my current from here to here. Okay, and after that I can simply connect my previous to my forward. Okay, and then I'm gonna do simply the same thing. I'm gonna make my current equals to my forward, so my current will gonna get removed from here and they will gonna point to this forward. Okay, now I'm gonna check again, do this this value of this current is smaller than this x or not. So as I'm gonna see this thing that this 6 is greater, which means this will gonna execute and my forward will gonna disappear from here and my current and my previous will gonna move one step ahead. So my previous will gonna come here and my current will gonna come here. As soon as my current become null, I know this thing that this is the sign where my linked list have ended now and I don't have to do anything. Okay, so now I got my two list. This is my right part and this is my left part. I simply have to connect this left part to this right part. So to do that, my tail always moves ahead. Like when you do this thing, when you make the current equals to forward, you simply can move your tail also ahead in the same loop. Okay, so that your tail always point to the last node, because it's important. Okay, you got it. This now if you want to attach this whole linked list here to this linked list, that means you have to connect this tails next to the head here. Okay, so I should have something for this. So I should know this thing that what will I call this. Right now I know this thing that this is my head. This is my head. So I can simply do this thing that make the tails next equals to my head. So when you're gonna execute this line, my tails next will gonna become this head. So it will, my whole linked list will gonna look like, so my 5, 4, and this is my head, and I'm making my tails next as my head. So this is the tails next, which is null right now, and it will gonna move it here. Okay, so this is my dummy, and this tails next is head now. So you can see this thing that this is what I wanted. From this 3 to this 6 is the list that I wanted in my answer. And this dummy node is extra, which we can delete later, or we can simply return my dummies next to get this linked list. Okay, and that's how you have to partition this. But there is still one edge case. Okay, right now I know this thing that this is my head. Right now I know this thing that this is my head. But many times it's possible that this head is deleted, because what if you got a smaller number than x at your head? Then you have to delete your head. Like you have to take your head and you have to put into the second linked list. So you're gonna lose the connection with your head and you will not gonna be able to execute this line. Okay, so we're gonna see that how that case we're gonna handle. And let's say the value of x that is given is still 4. Okay, so resultant linked list should be containing this 1, 2, this 3 on the left side, and this 5, 4, and 6 on the right side. Okay, so as I told you, this thing you have to take your previous pointer and you have to take your forward pointer. But if you start your, like, you have to start comparing from your head. You cannot compare from the second node, you have to compare from the first node. So if you make this your current, you should wait, what node you will gonna make your previous, because there's no previous exist. So as we don't have any previous, we simply can just make our own previous, and which we're gonna do by using a dummy node again. So I'm gonna use a dummy node here also, which I'm gonna call as, let's say, dummy 1. So this is dummy 1 and this is my current, and my previous is also pointing to my dummy 1. Okay, so as I told you this thing that what you have to do, you have to create a dummy 2 also. You have to create another dummy so that you can attach all of the nodes which are smaller than x. So this is your dummy 2 and your tail pointer is pointing here. This, let's say this is tail pointer, it's pointing here. So to declare both of these, how do you declare dummy nodes? You simply can write list node star dummy 1 is equals to new list node, and let's say you put 0 inside of it, and then you have to connect this dummy nodes next as your head, right? This is the head of the list, this is the head of the list, and this is the dummy, and you have to connect your dummy to the list also. So you can simply write dummies 1 next is equals to head. Second, you have to create another dummy, and before creating another dummy, you can simply declare another pointer which is going to be node star previous pointer, and which is pointing to your dummy 1. Okay, then you have to create another dummy which is dummy 2, list node star dummy 2 equals to new list node 0. Okay, this is for the purpose of creating another dummy, and your tail pointer, you will gonna declare your tail pointer which is also pointing to your dummy 2. Okay, so these are all of the declarations you have to do, and you have to declare your current pointer also, which you can declare by doing current equals to head, because your current pointer is initially pointing to the head, as you can see. Okay, so this is all you have to declare before moving to any loop. Okay, you created 2 dummy nodes, you attached dummy 1 to here, and you took your previous pointer to your dummy node. Okay, so that you can connect this dummy node to this too if this is smaller. So right now we can see we have to compare this to, so we were making 2 cases in the we were making 2 cases, right? So my first case was that if the current's value is smaller than x, then the first thing you need to do is you have to declare a forward pointer, which was forward pointer forward, which is equals to my current's next. Okay, so as I know this thing that this current here is smaller than this x, so basically I have to declare a forward pointer which is pointing to the next of this current, so that I can connect my previous to this forward. Okay, the second thing I need to do, I have to take this current pointer and I have to attach it to my dummies too. And I know this thing, my tail pointer is pointing to the dummy 2, so I can simply write make the tails next equals to my current, and then move my tail pointer ahead 1 step. Okay, so what did I did here, that I took my current pointer from here and I attach it to my tails next, which is, I'm gonna write 1 here, and then I moved my tail pointer ahead so that I can attach more nodes here by using tails next again. Okay, so now I have to connect this previous to this forward. So to connect this previous to this forward, I can simply write previous next is equals to forward. So that is all I have to write when I finds out this thing that node is having a smaller value than x. Okay, now I'm going to check again. So before checking, I should have my current pointer pointing to this node, because that is done, and I have to check for this node. So I'm going to point to my current pointer here. This is my current pointer, and I can remove this forward from now. I have to declare forward every time, so I can remove it just after my work is done. Okay, so to move my current pointer to the exact node, I simply have to write make my current pointer point to forward. So my forward pointer is basically was pointing here, and I knew this thing that this forward pointer is where my current should point after attaching its value here to this dummy 2. Okay, this is dummy 2. And now I'm going to compare again. Is this is smaller than x? So yes, this is smaller, so I'm going to do the same thing. I'm going to take this current and I'm going to make this as current next, which is going to be 2 here, and after that I'm going to move my tail 1 step ahead, and then I'm going to make my previous next as my forward. Okay, this is going to be my forward. My current was here before, so my current next is forward, and I can simply connect my this dummy 1 that is previous to my forward. And after that I have to move my current pointer to the forward, which is this, and my current pointer will be pointing here. Okay, again I can remove this forward from here now. Then I'm going to compare again. Is this 5 is smaller than this x? So I'm going to see that this 5 is greater. So when I finds out that my current value is greater than x, I simply have to move both of my previous and my current pointer ahead one step. So I'm going to write else if current value is greater or even equal, because if this is what I'm doing, this is what I have to do when it is smaller than x, then this is what I'm gonna do when it's gonna be greater or equals to x. So my current value should be greater than equals to, okay? Then I can simply write previous equals to previous next, and current equals to current next, okay? So I'm going to move my current pointer and previous pointer both ahead so that I can check for more nodes if they're not equal. So my current pointer will gonna point here and my previous will gonna point here now. Okay. Now I'm gonna check for this. Is this value that current is holding right now, it is smaller or equal to this x or greater? So I'm gonna see it is equals. In the case of equal, I still move them ahead. I still move both of them ahead. So my current will going to be this and my previous is going to be this. So as now the current value is smaller than this x, so I'm simply gonna rub this. Firstly, I'm gonna save this node as forward currents next. Then I'm gonna move my current from here to this tails next, and I'm gonna move my tail ahead. And then I'm gonna connect my previous next to my forward, and it will gonna look like this. Okay. And after that, I need my current back, so I can simply do make my current move to where there's forward is, okay, and I can remove this forward. All of this thing you have to do for the purpose if you want, if you're able to find that the value of current is smaller. So now my value of current is greater, so I'm simply gonna move both of them ahead. So my previous will gonna come here, and my current will gonna come here. Now my current does not hold any value and it's pointing to null right now. So if my current is pointing to null, it basically means that my list is ended now and I don't have to do anything. Okay. Now I know this thing, my resultant linked list should include this on the left side and this on the right side. So what if I, like right now this tails next is null, okay. What if I make this tails next as my dummies 1 next? So like this 5 here is the next of this dummy 1, right? What if I make my tails next as my dummies 1 next? Okay, so if I do that, this tails next will gonna point straight to this 5. It will gonna look like this. If in the end, if I do make my tails next equals to my dummies 1 next, okay, if I do this thing, this whole list will gonna look something like this. It will be starting from here and it will be going here. Now this dummy node that we took for the purpose of some help, and this dummy node that we took, we can delete both of these dummy node by using, so if you know that we delete the dummy node by saying, you can delete this dummy 1 easily, so you can simply write delete this dummy 1. Okay, to delete this dummy 1 from this dummy 2 from here, you cannot write delete dummy 2 because this node you need to save. Like if you're returning the list, you have to return the head of the list. So right now the head of the list is this. This is the head of the list, right? My list is starting from here. So you need a pointer for this list also. You can also return dummies 2's next. That is also totally fine. But you can delete this and then you can return this. So you can do one thing. Declare a pointer, let's say temp pointer, and declare that as dummies 2's next. Okay, so I'm going to declare a pointer which will be pointing at dummies 2's next. So my temp will going to be here, and after that I can simply write now delete my dummy 2. So when I'm going to delete my dummy 2, it will going to get deleted from here. As I delete my dummy 1, it will going to look like this. And I can simply return my temp in the end because that's what I want. I want this list to be my answer, and that's what I'm gonna get when I'm gonna return my temp. Okay, in the end you will be getting this 1 2, 3 pointing this here. So this is going to be your answer, and this whole will going to be your code. You have to declare all of these values first. Okay, declare all of these values, then check if this current value is smaller than x, then do all of these steps, then check if the value is greater than equal, then move both of them ahead, and then in the end delete the dummies node and return the temp value. Okay, your required linked list. So let's see on Leetcode how we're going to write this. So this is our question on Leetcode 86 partition list, and we're going to write the code for this. The first thing that we were doing, we were declaring our pointers. So firstly we were making our dummy nodes, which dummy 1 is we're going to make, which is going to be list node, and we're going to put 0 inside of it. You can put any value. And then after that I was attaching this dummy 1 to my head of the list initially, and then I was declaring my previous pointer on this dummy. Okay, it was just helping us out deleting the head and then preserving it. After that I have to declare a dummy node again to attach the list which have the small values than this x that is given, and in this I'm going to put 0 again, and another pointer which is going to be tail pointer, which will be helping us to connect all of the small nodes, and this will be pointing to this dummy node initially, dummy 2. Okay, so this is all what I had to declare. I have to declare this current node also. So list node star current, and it's pointing to our head. Okay, current node is the node which, current pointer is the pointer which actually compare the values, right? So now I have to run a while loop. I have to traverse the whole list until my current is not null. As we saw this thing before, that when current becomes null, my list is empty, so I cannot compare anymore. So in the while loop I have to write current value. If the current value is smaller than x, then simply save the next node of the current so that you can move your current back there again. It just helps us attaching my previous to it. Then this forward node is pointing to the next of this current, and after that I have to connect my previous next, or you can do for one thing that just make the tails next equals to your forward pointer. Sorry, not the forward pointer, you have to use current here. You have to attach your current, and then you have to move your tail one step ahead, tails next ahead. Okay, after this you have to connect your previous node to your current linked list. You're gonna do this by this, and you have to declare your current pointer ahead to your forward nodes to check further, right? After this, if your value is smaller, or if your value is equal or greater, then you have to simply move your previous pointer one step ahead and your current pointer also one step ahead. Okay, when you did both of these things, and you can simply come out of the loop and you will be getting two linked lists. Okay, one is going to be where this dummy 1 will be attached, and another will be dummy 2 will be attached. Okay, so in the dummy 2 one you will be having all of the nodes which are smaller. So I simply have to do one thing. I have to take the tails next, which is the last node of the dummy 2 one list, and I have to attach that to my first node of the first list, right? That is my dummy 1 list. So I can write that as my dummies 1's next. I don't have to include dummy there, and after that I can simply delete my dummy 1. Okay, because it's alone and we don't need it. Now I have to return the head of the list, and it will be having a new head, which will be dummy 2 will be holding that. So I'm going to declare another pointer. Let's say there is a temp pointer, and this temp pointer will be holding the dummy 2's next. Okay, then I can simply delete my dummy 2, and I can return this temp pointer, which is my new head. Okay, so let's see if it runs or not. So we can see our code is accepted. One thing, if you see here, that we can have an edge case in which my head is null. What if there's just no list? So if my head is null, this will never gonna execute because my current is pointing to my head, right? If my current became null, that means this whole loop will never gonna execute for that, and you can simply return after deleting the dummy nodes your temp, which is going to be null then. Okay, so let's submit our code. So the code is accepted, all 168 test cases passed. So hope you like it and hope you understood, and I'll see you in the next one.